briefly, I'm not going to do it all, but I'm going to at least set up number 7, because we've answered a lot of questions about number 7 so far. Okay, so Skype, let me ask you a question. Okay, let's say you borrowed $20 from me. Okay, which is pretty highly unlikely because I don't even think I carry around $20 anymore with me. I'm debit card all the way. You know what I mean? Okay. So, but let's say I had a 20 on me and you borrowed it. Okay, and we set up a repayment plan where you paid me $1 the next day, $2 the day after that, $3, and so on the next day. So kind of like what's going on here in number 7, where the factory owner borrows a sum of money, then the first month pays it back, then the next month pays it back with a little bit more, next month pays it back with a little bit more, and so on and so forth. Okay? All right? So, the next day, how much money are you going to give me? $1, right? Okay? So then how much money do you owe me? 19. Right? The next day you're going to give me $2, so then how much money would you owe me after that day? No. 17. 17, right? Because you already paid the $1 from the day before. Right? Then the next day, pay me 3, right? Okay, so then you'd owe me 14. Right? Okay? At the very end, when you are all paid up, okay, is that last payment going to be $20? No, because you don't owe me $20 at that last date, right? Okay? So $2,088,000 is not the last payment. It's the total that he or she or the factory owner borrowed, right? So that then is the sum of all the payments. Okay? Not A sub n, not the last payment, that's the sum of all the payments. Okay? What is 20,000 then? That's the first payment, right? So that would be A sub 1, not A1. That's what I put on my stakes, Claire. Okay? Alright? What's 1,000 then? No. No. It's what? What? It's your difference. It's your D. It's what the payments are going up by. Now, overall question, what are we looking for in this problem? What's the answer supposed to be? So so in arithmetic sequences and series, what is how many installments? It's what? It's n. So how many installments here is n. It's what we're looking for. Okay? Now, we've got two formulas that we can use, right? We've got the sum of the first n terms is n over 2 times a sub 1 plus a sub n. That's our one formula, right? Do you think we're going to use that formula? Why, yes. Why are we going to use that formula? I even color-coded it for you. Because we have the sum. So we're going to have to, at some point in time, use the sum formula. Because we have the sum. Okay? They're color-coded. Okay? What's the other formula that we have? The explicit formula, right? Okay? A sub n equals a sub 1 plus d times n minus 1. right? Now, can I use that formula to find the last term? Can I use the red formula to find the last term? Okay? Yes? No? I got no clue. We don't know what n is, so we can't, can we? Can't do it, because we don't have n. That's what we're looking for. If we had n, we could do it. Boom, bing, done. Easy, peasy, lemon squeezy. Okay? But we don't have n. So, we got to do some math. Oh, making us do math on a Wednesday. So we're going to take a sub n here, and we're going to put it in our sum formula. Because I said we got to use the sum formula because we have the sum. Okay? So the sum of the first n terms is still n divided by 2 times a sub 1, but now I'm going to add a sub 1 plus d times n minus 1 to it. Okay? Now you can start filling in stuff that you know. Okay? I know that the sum is $2,088,000. Do I know what n is? No. So n is n. Do I know what 2 is? Yep, 2 is 2. Do I know what a sub 1 is? What is it? 20,000. Do I know what a sub 1 is? Yeah, 20,000. Do I know what d is? It was purple. Do I know what n is? Nope, it's n. Okay? Now, you've got one equation with only one variable, n. So you guys can solve it from there. Okay? And it will take some solving to do. Okay? You might even have to do some factoring or some quadratic formulaing or some wonderful stuff. Okay? Good stuff. Okay? With me? So, we are out of the textbook today, and the textbook page is 488. We start on. Okay? So this is page 488. Okay? So, a geometric series is the sum of the terms of a geometric sequence. Just like yesterday, an arithmetic series was the sum of the terms of an arithmetic sequence. That terminology crosses over. Okay? Sequences and series cross over arithmetic and geometric. Okay? So, if we have the sequence 1, 3, 9, 27, 81. Okay? That's a sequence, correct? Because it's separated by commas. Okay? So that's a sequence because it's commas. If I wanted to write it as a series, I would put plus signs in between. Okay? Same thing. Okay? So, it's, what, 5 terms? We could probably just add it up, right? 1 plus 3 is 4, plus 9 is 13, plus 27 is 40, plus 81, 121. So the sum of that geometric series is 121, right? Okay. Well, we're going to meet 5 kids, okay, that are in Algebra 2. First one that we're going to meet, her name is Teresa. Teresa raises her hand and claims that she has a trick for quickly calculating the sum of any geometric series. Okay? She asks the members of the class to write any geometric series on the board. She boasts that she can quickly tell them how to determine the sum without adding the terms. Okay? All right? So here is what she says. So Paul says, fantastic. Here's a geometric series. He just continued on that one that we just did, right? And he went out, instead of the first 5 terms, he went the first 7 terms, okay? So what I want you to do now is, well, and then Teresa says, well, this is how I figured it out, okay? So what I want you to do now is, you and your shoulder partner, between the 2 of you, one of you do Teresa's method, all 4 of them, calculate it, okay? The other one, do Paul, Stella, Julian's, and Henry's method, just straight up adding them, okay? With me? Go for it. You got 2 minutes. All right, so in the first one, somebody that just added up Paul's series, what did you get? 1,093. Okay. Somebody that just added up Stella's series. Which one? You got Julian?
No, I did.
Oh, you did Teresa? No, yeah. We're gonna go down this one, and then we'll talk Teresa all at one time. Stella. 6,825. Julian. 1,560. 1,560. And Henry, 110, right? Okay, so that's straight up adding, okay? So now let's go over to Teresa. Teresa said in Paul's series that she took 729, multiplied it by 3, subtracted 1, divided by 2, okay? What do we get when we do 729 times 3 equals minus 1 equals divided by 2 equals 1,093. Hey, works out. I like it. Okay? Then she went on to Stella's. I will have the answer if I multiply 5,120 by 4 equals, subtract 5 equals, divide by 3 equals, what do we get? 6,825. Okay. Then Jillian said, no problem, multiply 1,250 by 5, subtract 10, then divide by 4. What do we get? 1,560. Henry was trying to be all sneaky. Okay? According to Teresa, her method still works. Multiply 160 by negative 2, subtract 10, divide by negative 3, and what do we get? 110. Okay? So question number 1 says verify that Teresa is correct. We just did, right? Okay. She worked out in all of them because we all got the same there. Okay? Question number 2 then says, what is her trick in words? Okay? In words, what is her trick? She takes the last term, the T word, okay? So she takes the last term. Then what, Vinny?
She subtracts my first term.
No, she does something first.
Oh, yeah. Multiply by the
It's an R word. Ratio. Okay, she multiplies that by the common ratio. Okay, then what? Then she subtracts the first term. more thing. What's that? She divides by what? Because we don't have a D in here because we're geometric. We only got R's. So what did she divide by? Let's go back and look. In Paul's method, she divided by 2. Teresa's method, she divided by 3. Or not Teresa. In Stella's method, she divided by 3. Julian, she divided by 4. Henry, she divided by -3. So it's not just she's not just willy-nilly dividing by a number, because it's different every time. In fact, it is. It's the common ratio minus 1. Okay. Now, let's put that into formula form. Okay. So, the sum of the first n terms of a geometric sequence is, how do we say last term in geometric sequence? Wrong letter. G sub n, because we're geometric now. Okay? G sub n times the common ratio. What's our letter for common ratio? R minus, how do we say first term? G sub 1 over, common ratio again was R minus 1. Okay. Ben, you going to write any of this down? Okay. I didn't even see you had a pencil up. Okay. What's up, Bryce?
Isn't there a separate one too?
We'll get to it. Yeah. We'll get to it. Yeah, Bryce. Okay. So there's the sum formula. So, now in number 3, let's use her trick to calculate what 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 is. So, we need G sub 1. What is G sub 1? G sub 1. The first term, right? We need the last term. We need R. 2, right? Multiplying by 2, so R is 2. Okay? So the sum of the first n terms is G sub n times R minus G sub 1 all over R minus 1. Okay? So that is going to be 128 times 2 minus 1 all over 2 minus 1. And there's 8 of those terms. Okay. 128 times 2 is 256. 256 minus 1 divided by 2 minus 1 is 255 divided by 1. So the sum here is 255. Yes? Add them up and check it out for us. Okay. 192, 224, 240, 248, 252, 254, 255. Yep. Okay. Okay. Works out. So the sum here then is 255. Okay. Teresa's trick isn't a trick really at all. Okay. Teresa's trick is something called Euclid's method. Okay. Now, yesterday we introduced you to summation notation. Okay. With summation notation in a geometric series, your R value is that term right there. In your rule, you need to look for the exponent. Okay? It's the base of the term that has the exponent on it. Okay? That's your R value. To find your first term, you still take the lower bound, plug it into your rule. That gives you your first term. To find your last term, you take the upper bound, plug it into your rule. Gives you your last term. Okay? That's the same. The only difference in summation notation is your R value is going to be that number that's got the exponent on it. Okay? So, on page, there they are, 490. Okay? You use Euclid's method here to answer those two questions. Go. So that's G sub 1. That's G sub n. And what's my R here? 10. Okay? So the sum, I don't know how many terms there are, so I'm just going to say the sum of the first n terms is G sub n, 1, oops, I should color code that, make it be official, 1,000,000, one more, times R minus G sub 1 all over R minus 1. So 1,000,000 times 10 is 10,000,000. 10,000,000 minus 1 is 9,999,999. 10 minus 1 is 9. So the sum of the first term, the first n terms here is 1,111,111. Okay. G sub 1 is there. G sub n is there. My R value is 2. So the sum here of the first 6 terms, because I know that there's 6 terms, is G sub n is 320 times 2 minus 10 all over 2 minus 1. 320 times 2 is 640. 640 minus 10 is 630. 2 minus 1 is 1. So the sum here of the first 6 terms is 630. Questions with Euclid's method? Teresa's trick really isn't a trick, it's known as Euclid's method. Yep. Okay. Okay. So, at the bottom of page 491, okay, I'm going to walk you through what they're doing there. Okay? So, but that's inside that spiral type notebook picture at the bottom of page 491. So, what they're saying is we just developed Euclid's method right here. Okay? And Euclid's method is great. It works. Okay? We just proved that it worked. Okay? But we can take this is our explicit formula for a geometric sequence, and we can substitute that back in. So if I do that, then I get S sub n is equal to G sub 1 times r to the n minus 1 power times r minus G sub 1 all over r minus 1. Okay? Well, I can do that math. Okay? Recalling back to my exponent rules, whenever I have the same base with exponents, I add those exponents, and this exponent right here is 1. So n minus 1 plus 1 is just n. So this becomes G sub 1 times r to the n power, then minus G sub 1 all over r minus 1. Okay? Now, I'm going to drop some F word on you. Okay? Or F word. Probably not the F word that you're thinking of, but I'm going to factor out G sub 1. Okay? If I factor out G sub 1, then I'm left with r to the n power minus 1 all over r minus 1. Okay. So we've just developed another sum formula, okay, based off of Euclid. Now, if you skip ahead to page 494, we're going to talk about those 3 geometric formulas that we now have. Okay? So the first one is the explicit formula. Right? Okay. So you might want to write down the explicit formula again. Okay. What do we use the explicit formula for? What? Finding any term, right? Or finding else can we use to find with the explicit formula? You did it a lot in arithmetics. What did you say, Ben? No? What else can we use the explicit formula for? N. We can find n with it. Yep. Okay. So that's what we use the explicit formula for. We use it to find any term in our sequence or series, or to find n. Okay? And that's all that that's used for. Now, these two down here are sum formulas. So what would we use those for? Find the sum, right? Okay? So, what do we need in Euclid's method? First term, last term, and r, right? If we don't have any of those, we got to use the explicit formula to get them, right? Okay? In terms of the one that we just developed, then, what do we need? What do I need to use that one? I need my first term. I need what, Max? Common ratio R. And then what? And then N. Now, will those two sum formulas get us to the same spot? Get us to the sum of the series? Yeah. Okay. You guys have probably heard me say many times, there's more than one way to get to Mosinee. Okay? The top one is taking 39 to Mosinee. Okay? Bottom one takes KK. Do I still end up in Mosinee? Yeah. Just went a different path, right? And really, the only knowledge that I can impart on you is that it really depends what you're given in the problem as to which one to use. That's really the only difference. Do I prefer the top one over the bottom one? No. I don't really care. Okay? It's really what's given to you in the problem or what you can find in order to use which one you want to use. Okay? They're both there for you. You now have two different screwdrivers in your toolbox. Okay? You got a flathead and a Phillips. They're both going to be used to screw in screws. Okay? It's just one might be better on certain ones than the other. Okay? So, let's put them to work here now on number 8, which is at the bottom of page 494, right below that. Okay? So, let's use this one first. Okay, we'll use this one in part A. Okay? So, what do I need for that one? I need G sub 1. How am I going to find G sub 1? No. It's not just the bottom number, as Megan said, but I have to take that bottom number and plug it into my rule. Okay? So this becomes 6 to the 1 minus 1 power, which is 6 to the 0 power, which is 1. Just so happened that in this case, they were the same, okay? But that's just pure coincidence. Okay? What else do I need? I need my last term. How am I going to find my last term? I'm going to take the top number and do what with it? Plug it in. Okay? So this is going to be 6 to the 4 minus 1 power, which is 6 cubed, which is 216. Okay? What else do I need? I need my common ratio. What is my common ratio here? 6. It's the base of the term that's got the exponent on it. Okay? So the sum here of the first 4 terms is going to be my last term, 216, times my ratio, 6, minus my first term, 1. Oops, that should have been green. Divided by my ratio, 6, minus 1. 216 times 6 is 1,296 minus 1 all over 5. That's 1,295 over 5. So the sum here is 259. Yes? Nope. Okay, with me? Now, let's use the other one in this one. What's different about this particular sum?
There's something on the left side of the
Out in front, right? Okay. So what do we do with that then? Do we add it? Do we subtract it? Do we multiply it? Do we divide it? Do we ignore it? What do we do with it? Do we do anything with it? I would hold off and I would wait. Okay? I would just do this part first. Right? Okay? So based off of that, what do I need? Now, I'm using this blue one, so I need my first term, right? What's my first term? It is not 0. It's 1, because I put 0 into my rule. I need R. What's R? 3. I need N. What's N? It is not 4. It is not 10. How do we find the total number of terms in sigma? Not 3. No. How do I find N? The total number of terms in sigma notation from yesterday. Top.
Oh, minus
Minus.
upper minus
Bottom. Plus 1. The kicker is plus 1. So top minus bottom plus 1 tells me that there are 5 terms in this series. Okay? Another thing where the terminology crosses over. So, the sum then of those 5 terms is going to be the first term, is going to be G sub 1 times R to the n power minus 1 divided by R minus 1. Okay? So 3 to the 5th is 243 minus 1 all over 2. So that's going to be 242 over 2. So that's going to be 121. Right? But now what do I have to do with that? Oops. What do I have to do with that now? Add 10? Multiply. When there's no symbol there, what do? Multiply. Okay? So this becomes my final answer then here is 10 times 121, or 1,210. Okay? Now, I'm going to hand out the green homework for tonight. Okay? Your green homework is due on Friday. So on Friday, we will have blue, yellow, and green all due. When do you think is a good time for you to do the green homework? Tonight. Okay? Tonight is the night to do the homework. Don't wait until tomorrow night to do your homework.